Welcome, everybody. Welcome to Dreamforce. Who's having a good time so far this week? Show of hands. Yeah. The show of hands is to make sure that everybody's sort of awake and let's get going and stuff like that. So we're going to talk about techniques, advanced techniques to adopt Salesforce DX and unlock packages. Quick show of hands, who's been using DX already? Yeah, okay. And how about unlock packages? The brave. I like it. I like it. So, real quick introductions. My name is John Daniel. I'm the Director of Platform Architecture for Rootstock Software. I've had a background in IT development for more than 20 years. Been on Salesforce platform for about 8 or 9 years, thereabouts. Multiple certifications, Platform Dev 2, a couple of Tech Art Designer certs, whatever. As far as Rootstock is concerned, we are a manufacturing, distribution, and supply chain ERP software, 100% native on the platform. So very excited about this. So with that, I'd like to introduce my good friend, John Story.
Hi, I'm John Story. I work for MillCorp. I am a technical architect on the software development team, or on the Salesforce development team. MillCorp is a contractor in the federal spaces, and just started up a Salesforce development team, probably I think about 2 years ago or so, and growing rapidly.
Awesome, awesome. And it's Thursday, it's day 3 of Dreamforce. Everybody seen this side, yes? If you haven't, come see me afterwards, we'll talk about it. So today's agenda, real quick, we're going to talk about a little bit about John's stories and my experience thus far with Salesforce DX unlock packages. We're going to get into a little bit of some open source frameworks that are available out there and that we've been using. And then finally, we're going to go over a lot of different scenarios that we've been dealing with, we came across during our adoption of unlock packages specifically. So I'm going to pause right here. I'm going to tell you folks, we have less than 30 minutes now to really jam about 3 hours worth of conversation, probably more into it. I guarantee you, you will have links to get more information. There is an entire code base sitting up on GitHub ready to go for you guys. I promise you, you will have all the information that you need. And if you don't, then contact me later and we'll get it straightened out. So with that, we're going to get going. So real quick, our experience with Salesforce DX and packaging. John and I used to work together. We've worked together actually in a couple of different places. We worked together on the professional services team at Financial Force, and then again, we worked at a large law firm. At the law firm, we were one of the first enterprise customers to adopt DX and unlock packages in a systematic and scalable way. And Salesforce got excited about it. They showcased the approach, and we're going to continue on that progression here. These are 2 talks that have been given. There will be links that you can go and listen to these on YouTube and whatnot later on. So I highly encourage you to get all that. That talks more about the story there. So with that, John, tell them about FFlib, please.
FFlib. For some of my friends in Europe, it's called Flib. So if you hear me call it Flib or something like that, you know what I'm talking about now. All right, it's an enterprise application engineering patterns that have been tried and tested in many platforms and languages around the development industry. It's based upon a book by Martin Fowler called Patterns of Enterprise Application Architecture, and then also using a lot of the stuff that Andy Fawcett wrote about in his book, Force.com Enterprise Architecture. FFlib enables proper implementation in the Salesforce arena of some of the solid things that I use solid all the time, separation of concerns, making sure things are contained in a very cohesive manner. Interface-based programming, so that we kind of start that decoupling process, and dependency inversion, which is going to be probably the biggest part of this whole conversation. FFlib provides several areas that are the biggest areas of the framework: an application factory, selector factory, unit of work, domain layer, and service layer. First, the application factory. It's centralized logic that allows us to get instances of classes and objects based upon abstraction. And then it also facilitates mocking. It allows us to inject pretend classes, pretend data, and stuff of that nature to help us unit test. We'll talk about that a little bit more. It provides a selector pattern, which encapsulates our SOQL logic. provides a unit of work pattern, which separates our DML operations. Domain functionality, which is an encapsulation of logic related to a particular S object and can also bring together the trigger handling functionality. And the last big item that it provides is a service layer, which is a portal through which many different users can get to your business logic. Layers like your UI, APIs, Apex Web Services, stuff of that nature. Apex Mocks is another big thing of the FFlib framework. It allows us to really unit test our code. And that uses the Apex Stub API. Through the elimination of dependencies and such, it allows us to target a little bit closer on the code that we're really after. A lot of people, I'm sure, we'll talk about Apex mocking in just a second, inspired by the Mockito framework in the Java world. Okay, how many people have a process like this, where you have to, I want to be able to test the return product restock operation that goes on down at the bottom. Well, for me to get there, all these layers depend on each other. I have to create an account, then I have to create a contact, and the contract is given to the opportunity functionality, and we start building. So if I want to test this, I've got to create all these items. If I insert them into the database, it's going to queue off validation, it's going to queue off some triggers and stuff that start doing other things, and pretty soon we start getting too many SOQL calls, CPU timeouts, DML limits, and stuff of that nature. So don't do it. It's a potentially disastrous thing as far as your unit testing. And it's actually not unit testing, it's called functional testing. With Apex Mocks, you can create just an object in memory, add a few items to it, and then you can create a mock selector, and you can put that object in it, or a list of objects that you create. Give that selector to the application factory so that when I call my code that I want to test, it gets that mock selector that has the mock data in it, and I didn't have to go through that big list of things to create all that data. And also, how long does it take some of those big, long process things to run? I know I've sat there for 10, 15 minutes waiting for long-running tests to complete. Stuff like this should complete within a minute or so. Force DPI.
Yes.
Or Force DI.
Force DI. So a lot of the things that we were doing were all around dependency injection. Over the summer, Andy Fawcett, who is the VP of Engineering at Salesforce, decided to go out and start making an open source framework. He's talked about it quite a bit. So Andy Fawcett, Doug Ayers, who's another, the person who works at Salesforce for Trailhead enablement, and then myself developed this framework. It's based on Google's Java Juice framework, so it has got a lot of road mileage and thought process already built into it. It aids in eliminating compile time dependencies, and which is going to be essential when you're taking your org apart and put it in packages. And it provides, it's a very powerful framework. It provides dependency injection, not just for Apex classes, which we're going to use it for, but a lot of different other things. And I highly encourage you to check out the links later. It's a whole nother subject matter right there. So with that, let's get into the first scenario and things that we dealt with. First of all, just a quick show of hands, those people that have used Apex Commons, how many people know what I'm talking about when I talk about the application factory? Good. All righty. So what it is basically it's the application class. It's responsible. It's part of the Commons framework, and it's created to maintain the mappings of all the different class types that need to be instantiated through the org. So it becomes a one-stop shop to get all the classes and information that you need. But it also provides the ability to inject mocks during testing time without necessarily changing codes, without having complex if logic, like if this is in testing, use this mock, otherwise use the regular path. So it's very, very powerful concept, very powerful pattern. But at its heart, it's statically compiled dependency injection. So what I'm talking about here. So this is a traditional application factory. It provides the mapping for all the constructors to the FFlib framework. It provides them for service classes, selector classes, the domain classes, and it also provides the objects that need to be organized for the unit of work. But in doing so, it has a dependency on every single class going. So why is that a problem? So take, for example, you want to create a couple of different packages in your environment. We'll say, for example, marketing, sales, and service. The question is, you're eventually going to have to map and put everything into some package. The question is, where are you going to put your application class? You could put it in the marketing package, but the side effect is everything will now depend on your marketing package, and that's not where you're going, not where you want to look for. So the marketing package is not really a good option here. So in our experience, what we found is that having a baseline core package to put the application factory in is the best approach, because then each of the different business unit packages can depend on that core package, and they don't have to have interdependencies amongst themselves. The core package will depend on the Apex lib, or excuse me, Apex common, Apex mocks, and yeah. So, but that still leaves us with a little bit of an issue, because you've got all those selectors and domain objects up in the business area. So the campaigns domain, the campaigns selector. How do you get that back into the upstream dependency of the common or the core package? So the way to do this is to dynamically inject the classes that you're looking for. So what we're talking about is, first of all, we set up a custom metadata record type in the core package. This is responsible, actually there are several of them, and they're responsible for maintaining the mappings that you previously saw in the old. So the marketing package on the left adds a custom metadata type record. In this case, it's the selector binding for the campaign S object. That maintains or expresses the mapping from campaign S object to campaign selector. Using the Force DI framework, we now can let the application factory inject, based on the information that it sees in the custom metadata record, the campaign selector. So just a little bit of interesting code. So when you look at the campaign selector, if you're familiar with that pattern, you always have the new instance method, and that new instance method always offloads to the application factory. So in this case, that doesn't change. Please take note that we're extending the application S-object selector. So you'll find that all of these techniques, we have basically put a new group of base classes together. They all extend the fflib counterparts, so rest assured your code will still be working fine there. But they do take advantage, and that's where all the magic is working right there. So if you look at the application factory, what we did was just basically take all of the guts out of the fflib version and rewrite it so that we can get at the dependency injection. So on line 33, you see where the Force DI framework is actually injecting an instance, in this case of application S-object selector and the S-object type. And then we use custom metadata records to actually hold on to the mapping. So now let me back up real quick. So now when we install the marketing package has with it the custom metadata record, it has the selectors, and now all of a sudden application factory can look inside the custom metadata type and see what's going on, instantiate the class, just easy as can be. So John, next thought, please.
Okay, one of the first problems we encountered was the fact that if we had a downstream package that came in that wanted to provide a field to an upstream S object, how was the upstream selector supposed to know? All right, so what John just talked about, I'm going to start working with the account object. All right, the account object is really not a library, it's not a framework or anything of that nature, so it doesn't go in the core package. So what we used was a common package, which is where we put the account, the user stuff, any sort of common stuff that's going to be used by most of my downstream packages. So now we have this marketing package, and the marketing people have said they want a slogan put on the account object. So they want to capture some information. They think it's going to help them with sales and stuff of that nature. So since that goes in the marketing package, how does the account selector supposed to know to add that field to its SOQL query? All right, and that's the problem that we're facing at this point. And like John said, we're going to do this selector field injection via custom metadata-driven dynamic dependency injection, so that any consumer of the account selector will get this new field that a downstream package has added. All right, so here we have the marketing package, and I've also created a field set that contains this new slogan field. And when it installs, or maybe later on, what I'll do is I would add a custom metadata record that associates the account S object to this field set containing the slogan field. Now, whenever I need to use the account selector during instantiation, well, another point here is that, as John mentioned, it also extends a class in the core library that extends a FLIB S-object selector. All right, so this is where we put the dynamic injection functionality using ForceDI, where it will read from the custom metadata, it picks up all the records, and then inspects those field sets and gets the fields out of them and adds them to the SQL query that drives the whole thing, so that any user of the account selector is going to get this new field that we've added. My little bit of interesting code in this is in the upper left there, you'll see my custom metadata record, where you see the mapping between the account and the field set. It's not exactly the same. I kind of copied that from someplace else. And then also I got down here in the code, you can see in the red box, on line 8 is where I'm using the account selector. Nothing special. I'm just selecting by ID from an ID set. And then when I go through and do my work, there's the account slogan field, and I'm not going to get the exception that the field wasn't queried. It's already built into the S-object selector, and anybody else who uses it gets that field as well.
So a third technique is, we call it domain process injection. So again, back to our example, we have common now in there. It's responsible for. What we found is that each package needs to be responsible for an S object. It can be responsible for multiple S objects, but what we generally found best is an S object can only be, one package can be responsible for an S object. So that means things like common is responsible for the account selectors. Just as we're talking here, the accounts domain class is one of them. And the domain logic classes are all about the logic and the business logic specific to an S object. So as John pointed out, our account.slogan field has been added by the marketing package. So when the marketing package is installed, the account object now has that extra custom field. Now, follow the example or the use case here. We're saying here that marketing has required the use of the slogan field going forward. And we're trying to figure out, okay, well, that's great, but how do we normally put that information into the account? Normally, when you would be doing this, well, actually, let me back up a little bit, sorry. Let me talk about what I mean when I'm saying domain process. So normally, what you would end up doing, this should look familiar to anybody who's working with the fflib pattern. This is a basic raw accounts domain class. It extends the fflib S object domain. It has override methods that you can override various trigger events, in this case, on before insert. And then you have some level of logic. So that logic is captured there, and that's what we're trying to work with. Now, when you generally break down domain processes, I found that it usually falls into one of two thoughts. Domain processes have criterias. They are criterias or filters. You take the records that are part of the domain, you filter them down, so that you can then perform one or more actions on them. So if you think about your domain logic in that kind of two-step approach, breaking this out actually becomes a little bit interesting scenario. So again, we've got marketing. It depends on accounts or the common package. It depends on cores. It is adding the slogan. So our method on the previous slide, prepare fishy slogans, is what we would normally do when marketing says, hey, I want every account in the system that has the name fish in it to have a slogan of the account name is a fishy business. So sorry, that's a really terrible example, but still, there it is. What we're going to do is we're going to break out the logic of each of the domain processes. We're going to separate them out into distinct classes. So in this case, we'll put the criteria class up in the marketing. And then we'll also put an action class together in the marketing package. Those two classes depend on the core interfaces and abstract classes that we have available. And then, again, you'll be able to see that. And then just as before, we've got custom metadata type records that are going to manage the whole process. And so again, our previous method, it has a criteria. And again, this is a very simple criteria, not a big deal, but it's a good illustration because now we're going to take it over to a distinct class unto itself. The criteria class implements, among other things, the iDomain process criteria. Again, we've got code waiting for you. It has a quick method, a contract to deal with what records should I be looking at. And then finally, it has a method that says run. And the output of this is just to filter the initial result set down to a lower, smaller subset. But it still maintains the criteria that we had before. The action portion, in this case, we're going to assign the slogan to be the account name is a fishy business. We translated that into a different action class. So it's a distinct class. Again, it honors a specific contract. The contract in this case is really extending an abstract action class, which really is managing several different interfaces. Again, it gives you lots of flexibility in the framework we've gotten built here. But the simple method of run in process. So all I need to do, is fill this method in with the action that I want to take. Now, what brings this all together is a custom metadata record. Now, this one's a bit more complex scenario. So the domain process bindings allow you to orchestrate criterias and actions together to form a single logical domain process. You control the sequence of events. So it sorts these binding records in the order of execution order. You control the execution context. So with this framework, you can deal with some sort of trigger type execution on the account, maybe before insert, maybe before update, whatever you're looking at. You can probably do multiple records, before insert and before update. Or there's a domain method token there, and so if you were invoking a method directly from the domain class, say from a service, you would be able to do it this way. But this shows you the types of records. It breaks them down into criteria and action. And then finally, it shows you which class should be injected. Now, this represents a more advanced case of the way to deal with ForceDI framework setup, and so that might be helpful to look at as well. But when the process executes, when the trigger, in this case, executes on the account before insert, it scoops up the base domain class, scoops up all of these records, figures out the order. It will execute all of the criteria first. Whatever that result set is, that subset of the records, it will then pass them through the actions. And I can actually define multiple streams of domain processes in this way. But the beauty is, I can leave these classes up in the marketing package that has a dependency on the common package, but I don't have to open up and change my account's domain directly. So the injection allows me to honor, among other things, the open and close principle, at least in this particular thought process. I don't change the account's domain. The account's domain still is in the common package, but now I can alter its flow and work with it a little bit more directly. Next thing, John.
All right. Test data field injection. In the area that we were in, the company that we were working for, and we started adding some of this stuff, along came one day, they decided they wanted to make a field required. All right, well, remember that we have in the common package, we have the account functionality. And we also have, up in that area, a bunch of unit tests that use the account. Now, these unit tests really don't know anything about this new slogan field that we've come to use. And marketing has said that this slogan field is so wildly popular that they want it to be required now. Well, that's nice, but I have a whole bunch of unit tests using DML-based functionality that are probably going to have some issues. And I add a little line there, oh no, I know I should have used mocking, but this was stuff that existed long before I got here. So I've got to manage it now. I've got to do something with it. I don't have time to go back and rewrite all these classes using mocking, so I'm going to have to do something that's going to allow me to make my test pass. All right, let's look at this test, for example. we have an account that we're running through a test here. I create an account. I add a couple fields that are very specific to my test. I'm going to use these in my test to make sure that they do something. But on line 21, I'm doing an insert of that account. And notice I didn't provide the slogan field, so what's going to happen? The validation is going to kick off and say, invalid field, and it's going to cancel the rest of my test. So there's my gotcha right there. And that's all over the place. How am I going to solve that? Well, the marketing package created this problem. They're going to solve it. All right? Again, using dynamic dependency injection via custom metadata, the marketing package is going to provide a test context only class that supplements accounts with any sort of data validation requirements or other stuff that you need to make the test run. All right? So in the common package, we have that test that has the insert account. All right? And it's going to fail if I don't do something about it. So we put the magic in the core package. We create a test data supplementer class. Whenever it instantiates itself, it first reads from custom metadata for any, in this particular scenario, for any account that I'm processing, I need to go use this marketing account supplementer class. I need to invoke that. All right? So now back in the account usage test, it creates its account in exactly the same way it did before, but instead of just going straight to the insert, it passes the accounts to the test data supplementer class. It, via a test data supplement interface, is going to call off to this marketing account supplementer, which implements the interface. And now, in there, it adds the slogan field to these accounts, gives it a sufficient value, or does whatever magic it needs to make it meet whatever requirements the marketing package knows about, passes it back through the test data supplementer, back to the account usage test, so that now I have an account that has all the stuff I need to go ahead and do my stuff. And it's not going to at least die because of the validation rule. All right, again, a little bit of interesting code here. This is the Force DI code that reads the custom metadata and pulls those in, and we iterate through and this is an example of the custom metadata where you see the account and the supplementer's name. I should highlight this in red. Maybe I'll do that for the next presentation. And then we take that information, we put it into a structure, and we save that off so that whenever the test passes the S objects into this particular class here, now it iterates through any of the supplementers, gives the accounts off to it supplements them, and we might have others. So it passes it off to this test supplementer, passes it off to another test supplementer in other packages, and adds the information that are needed to help it pass its tests.
Awesome. So the last big issue that we had to solve was we had lots of different packages in our org, and so we had to deal with the concept of how do you talk amongst the packages. So, Salesforce, we've all heard that Salesforce recommends that you have one trigger per S object, and that is still true even in the world of packaging. And say, if you remember the example, we had the marketing, the sales, and the service, and say sales and marketing want to watch out for slogan field changes, or something that might be done via email or chatter. And so we're looking to respond to specific events. And so the issue is, I might have a change that goes onto the account, but how do I tell the marketing package, the marketing logic to go ahead and respond to it? How do I tell the sales logic to go ahead and respond to it? One thought would have been to add account triggers in all of the different packages that I want, but then that would violate the original, best practice recommendation of a single thought. And so we obviously don't want to do that, but instead in the common package, which is the package that assumes responsibility for the account object, it has an account trigger already in it. We'll just work with that to start with. So John will tell you how we figured this one out.
All right, this is how we figured this one out. All right, again, you've heard the common theme so far. We're going to use a dynamic dependency injection. Everybody say that. Via custom metadata. The event distributor can, the event distributor can dole out these events to whoever is subscribing to them using some form of filtering functionality. Like, I don't want to listen to every event that comes across a wire. I just want to listen to these. So there's an element of filtering that's involved here. All right, let's say in the common package, we have an accounts trigger and somebody changes something. All right, so what it does is it publishes a platform event. In the core package, we have a platform event, we have a trigger that kicks off the platform event distributor. On instantiation, again, it goes to custom metadata and it reads the records that are associated with it. It picks up some filtering information and a consumer in these different packages. You can see a consumer for the marketing package, you can see a consumer for the sales package there. It compares the subscribers' configured information, how do I want this, or what do I want, and kind of filters on that. It's not going to send these consumers information that it doesn't want. And then it distributes the events off to the consumers. And that's my phone, go kill it. Sends them off to the consumers, and then they have their data. We haven't done anything with them, but then we're going to kick them off in a batchable mode, so that the process that started this whole thing can shut down, and the user can do whatever he needs to do. All right, and here's where it's distributed off to the marketing and the sales packages through this events consumer interface. And those then do whatever they need to do. In this case, in our scenario that we had talked about, it creates email messages and chatter messages to the people so that they know the slogan has changed, so that next time they call their customer, they can say, hey, how's your fishy business doing? All right, a little bit of interesting bits of code here. This here is the trigger in the accounts class, where you can basically see that it's creating the event message. And here's a little bit of example of the custom metadata that we had, where we have the matcher rule. It's kind of saying, I want anything that has to do with the event bus, the category, and the event name. If those all match, send me the information. There's the event name. There's the event bus. In our particular case, we had, I don't know, I think we had two event buses, but mostly it was this event bus here. And anything to do with the account, it'll send it, then it sends it off to this is the consumer code that I just popped up, and you note that it implements, oops, go back, thought I had more. It implements that event consumer interface. And there's, in line 16 is the set events. That's where it first calls up and says, here's the records that, you can go kill that for me. It's going to bother me more than anybody. Yeah. All right, and where you put the events in, and it saves those, so that it comes back in a queuable context, and it executes those and does whatever it needs to. Creates chatter messages, creates email messages, and we get the opportunity to communicate all this information to across packages.
So, all right, so that is, again, 50,000-foot view of a subject matter that is quite deep. Again, we're going to post this slide deck to the session chatter tonight. Take the photos real quick, definitely that. That'll give you the more information. The demonstration code base is the first link. Other things that I want to point out, again, we were talking about that we have done this presentation and showcased this with Salesforce. These are the other two presentations, back from Trailhead and then over the summer, and I'm going to come back to it. Again, I will recommend two books, please. First off is Dan Appleman's Advanced Apex Programming. The 4th edition was just released last week. I cannot promote this book enough about how it talks about how to think in the world of Apex, how to organize your code base. If you haven't seen it, please get it. The second book, Force.com Enterprise Architecture, again, we've already alluded to it. It's a required reading if you're going to do anything serious in the world of Salesforce Apex development. So with that, we've got Q&A. There's a mic right there. If anybody has any questions, and I'll post some of the links back up real quick, just in case. Yes, sir.
What did you say?
One challenge I've had with the fflib selector is getting more data than I want for a given S object,
right.
For a given context. I didn't hear if this, what you described today could address that issue, but I was wondering if it does.
So the question was, what do you do with fflib specifically? Which fields do you subscribe to? Which ones do you select? The trick is to find the minimal amount of set, and then maybe through certain methods, maybe you want to add on to that, but you're always guaranteed that minimal set, and that's just a standard technique. Yes, sir?
So does it support interclasses in terms of the enumeration of the various handlers that the domain class dependency injection uses, so you don't have a zillion classes that you end up creating?
An enumeration of classes? Maybe
No, inner classes.
Inner classes. Oh, does it support calling inner classes?
Yes.
Yes, it would. Yeah, because again, it does, at the heart of it does the type.for name, which supports inner classes or package classes from that side. Yes.
Yeah, quick question here. In your managed package, you have some custom field, and how do you prevent user to reuse your field name? So one with namespace, one without namespace. So when you run in a package, when you run dynamic circle, it's going to be duplicate fields, right?
So within, all right, so the question is how do you prevent two different teams from using the same exact name, say, on the account?
Yeah.
Your teams have to talk. There's no two ways about that.
Yeah.
There's no getting around that. There's no, I mean, because in most of the time in enterprise scenarios, you're going to use unlocked packages. My recommendation is not with a namespace. I don't personally see value with namespace unlocked packages in an enterprise setting. So you're all in the same namespace. You still have that problem. If you had 6 teams and they all wanted to add a slogan, you're going to have to sort out who has responsibility. You may bring it down to a common package that is specific to a couple of teams instead of the entire group. And so, but again, it's something that you're just going to have to work out amongst the teams, find out where it places in the hierarchy and the dependency tree.
Different ways to do it, yeah.
So unfortunately, there is no silver bullet there. Absolutely. Sorry.
Thanks.
Yes, sir.
Hey, my question is about the drawbacks, about maintainability. Is it getting harder to like debug stuff and understand what the code actually does when you have this layer of indirection? Like the question is, do you suffer from problems that other DI frameworks like Spring?
You would.
What's your
Yes,
experience?
there would be the same type of issues that you would run across, and even in those environments, it's really about how many breadcrumbs you leave along the way to make sure that you can look at the entire log and see what's going on and digest it and understand it. And so those challenges don't really change in this environment, they don't get better. Let's say it that way.
But you have to look at the custom metadata to understand what is injected where.
You have to be
There's no
looking at that.
code
side.
that you can read through and
Right.
get what's actually going on.
Yeah, and that's I view that as one of the prices to pay that when we're going into the world of unlocked packages. So I mean,
we
we
should
can't
not-
keep all the logic in one spot anymore.
So we should not do it everywhere. Maybe you should add that.
Where does it fit? You know, like every tool. I mean, not everything's a nail, so you can't use a hammer on everything. You know, it kind of depends on what you need. I mean, it helped us in a little bit that you could have these packages that I could put in a Scratch org, and I could work on this one particular package. I didn't have to worry about all these others. But definitely, you can go way too far, getting way too granular, and you know, your head is spinning with all the custom metadata you have floating around. So,
for certain, it is definitely one of the issues that we have to contend with. But when I compare that to the trade-offs of developer onboarding, for one, I mean, that for me was one of the selling points of unlocked packages. Instead of having a new developer look at the entire org and try to understand everything about it, I could focus him on one package or 2 packages and say, this is your life, figure this out, we'll move on to the next thing from there.
Cool, thank you.
Thank you.
Talk.
Thank you. Yes, sir.
Similar question on drawbacks. Do you notice any appreciable performance impacts with the indirection stepping through multiple classes in this way?
So I haven't noticed anything. Now, full disclosure, I haven't put it through millions and millions and millions and billions of records and stress testing either. Our situations haven't come across that. Querying custom metadata is almost as good as querying or dealing with custom settings. So you're not taking a SOCL hit on the queries at all. And instantiation of classes is getting faster and faster every day. I haven't seen any kind of degradation in performance whatsoever.
Great, thank you.
Thank you.
Hey. Is there an expectation that the people who are going to make changes to the configuration custom metadata are not necessarily going to be the same people that are going to be doing development? And if so, what sort of testing do you have in place to make sure that no one does anything silly if they're only changing configuration?
You're talking about a process question, not a technical question, in my mind. I think the developer who is carving out a particular piece of logic would most likely carve out the custom metadata to activate that logic as well. Preventing people from being silly, Yeah, if you figure that out, you know.
Restrict access to the custom metadata to people who can actually make the changes.
Yeah, I mean, there's a process. You're talking about code reviews. You're talking about the review process, the testing process, and at least in my mind, I mean, I can't think of a way to prevent somebody from being silly.
Okay.
Yeah, I wish I had a better answer. Yeah, thanks.
Hi guys. Hi, I'm Anton. Thanks, very good presentation. I'm really excited about what you're doing here. Any plans of Salesforce to get it incorporated? Because you know the whole trailheads and enterprise patterns have now been there, right? So
There is no plans. I'll say that Salesforce has been watching our progress over the past year, especially. They like what they're doing, what we've been doing. It's way too soon for them to say, well, we might start promoting one approach over another.
Fair enough.
We can definitely say this approach works.
For us, in our
Well, I mean, yeah, I mean, definitely for us, but this works. And right now, with the adoption of DX and packaging, that's important to see right now, you know what I'm saying?
okay. And then a bit more detailed question actually. So the criteria and actions you had distinct, right? Have you considered basically combining them in one?
Sure,
right?
sure. I mean, you can do it like the other gentleman was talking about, interclasses and designing a whole criteria object and
It's more
reusing
like
them.
You've basically, instead of just one interface that does the filter and mapping, you basically created two interfaces, one for
Right.
filtering, one for mapping, right? It's just, it did that.
We didn't do it. We haven't come across that need yet. Not to say that it can't be done. Either.
fair
So,
enough.
with that, thank you very much. If you have any other questions, we'll meet you outside.